Assalamu alaikum, welcome to Nasirsoft. This is the data manipulation and cleaning tutorial series, and in this video we will talk about one of the important topic in machine learning, that is feature engineering. So in this data manipulation and cleaning tutorial series, you have learned about not only theoretical but also practical about all these three topics in the three different videos. The first one is handling missing values, the second is outlier detection, and the third is normalization and standardization. And in this video, you will learn about the feature engineering. So in this video, you will learn about the feature engineering, all possible topics, that is feature creation, feature transformation, encoding categorical variables, feature selection, and dimensionality reductions. And you will also implement all these topics in Python. So in this video, step by step, we will implement all these feature engineering topics with examples in Python. I will show you step by step with example and how with the output explanation also. So let's start. So the code link is mentioned in video descriptions, so you can download this. Let's start. So what is feature creations? Feature creation involves generating a new variable, as its name indicates, or features from existing one. Okay, so we have the arithmetic transformation. For example, you can combine features using the arithmetic operation like and or something like. You have, if you have a domain knowledge of the data set, you can add a new column. For example, use industry specific insight to create a meaningful features, and interaction features multiply or combine variables to capture relationship. So let's implement the feature creation in Python. Code link is mentioned in video description. You can download it from the that specific link. Okay, so let's start from the feature creation. In feature creation, for example, we import the pandas, and inside the data we create a data. We have height of 5.5, 6.0 and 5.8, and weight is like this. Okay, and with the panda data frame, okay, we basically create a data frame, and now we will create a new column, that is the BMI, on the base of weight and height. As we know that the BMI is basically the weight divided by the square of height. Okay, so we create a new column BMI, and to the weight divided by a square of height. Okay, so that will store inside the BMI, and when I will print out here, you can see that a new column is created, a new feature. If I said a new feature we creates based on height and weight. So this is the feature creation. You can create a new feature based on the existing one. Okay, so let's move to the next topic, that is feature transformation. Implement the feature transformation in Python, we use the NumPy library, and we apply the log transformation to our column of weight through the np.log method, and we create a new feature, name is log underscore weight. You can also apply the standardization. Standardization is we apply to this basic formula of standardization, that is for each individually column minus the mean of overall that specific column divided by the standard deviation of that specific column or feature. Okay, so we name a new feature is weight underscore std, and the third one is we apply the normalization. So basically we transform the weight with the weight normalization, and we create a new method that name is weight normalization, and through the normalization basic formula, that is specific column minus minimum values divided by maximum minus minimum. So I already explained this in the normalization and standardization sections on second video or third video of this tutorial series, so you can wait. So when we print out here, you can see that this is the original column, height, weight, BMI, and then we create the three more columns, that is the or features, that is log weight, log standard deviation, and log normalization. Here you can see this, how you can apply the feature transformation in Python. So let's move to the next topic. So next topic in feature engineering is encoding categorical variable. Okay, so mostly a machine learning algorithm works well on the numeric format of the data, not on the categorical related data. So how you can convert the categorical data into numerical formats, okay, for machine learning models? So we will use the encoding methods. Okay, so in this video we will talk about not only theoretical but also practical of all these five types of encoding. Okay, so the first is label encoding. In label encoding, we assign a unique integer to each category. We will see it later in coding side. Okay, so one hot encoding creates a binary for each column. In the target coding, we replace the categories with the mean of targeted variables for each category. In the ordinal encoding, we basically assign ordered numerical values to categories based on the defined order. And in the binary encoding, we convert categories into binary digits, reducing the dimensionality compared to one hot encoding. And we will see it later what is the difference between the one hot encoding and the binary encoding. So let's implement this in Python. So this code is mentioned in video description. Okay, so inside the encoding categories variable, the first is label encoding. Okay, so inside the label encoding, we assign a unique integer to each categories. For example, in if our data set is like the colors like red, green, blue, so we will assign some integer to red, some to green, some to blue. And when the red repeats, okay, so for example, in this example, for example, if we assign the red to 2, then it's mean our in overall data set the integer 2 will represent the red values. Okay, in order to implement this, the label encoding in Python, we use the library that is sklearn.preprocessing, import the label encoder, and through that label encoder object, when we pass this color, okay, as the color feature as a label encoder, and we create a new feature that is called color encoder. And if we print this here, you can see that the red is assigned the integer value of 2, green is 1, the red is repeat, so again 2 comes, and blue is 0. So here you can see this is the how you can implement the label encoding inside the Python. Okay, let's move to the next encoding technique, that is one hot encoding. Inside the one hot encoding, we creates the binary, for example true, false, or 0 1 columns for each category. Okay, so through these pd dot get dummies, okay, we pass the overall data frame, and we basically tell in which column you will apply the one hot encoding. And if we print out here, you can see that it creates more featured, that is for each individual, for we have the unique values, for example the red, green, and blue. So the new three columns or feature is created: color blue, color green, and color red. And it assign the true false values. For example, the first value is red, it's mean that the color red is 1, the color red will be true, and remaining will be false. Okay, the second column is green, so it means the green column will be true and remaining will be false. So this is how the one hot encoding works. How many features inside our how many unique values inside a categorical objects will, okay, so the number of unique columns will be created against each unique values. Inside this we have three unique values, that is blue, green, red. So we have in the one hot encodings creates three more features or columns. So basically it increase the dimensionality of high coordinality. Okay, so therefore in most interviews they will the interviewer asks the question about what is the one hot encoding and how it increase the dimensionality, so you can answer this. Okay, so let's move to the next encoding technique, that is ordinal encoding. In ordinal encoding, we assign the ordered numerical values to categories based on defined order. Okay, for example, if our data set is like size, that is small, medium, large, something like, and we will assign a customized value, for example, small to 1, medium to 2, and large to 3, something like this. So this is called the ordinal encoding. Mostly we will assign this in when we have a lookup like data. Okay, like for example educational qualification data like MSc, BSc, bachelor, or something like, so we can assign a unique integer to each. Okay, so let's move to the next one, that is binary encoding. This is very very important. So in order to understand the binary encoding, so you first need to understand the one hot encoding. And you see that in one hot encoding, it increase the dimensionality of the data. Okay, so when we works on the binary encoding, so it's just like a one hot encoding, but the one unique idea is it decrease the dimensionality, it not increase the dimensionality like the one hot encoding. So okay, so inside the binary encoding, it converts categories into binary digits reducing dimensionality compared to one hot encoding. For example, if our dataset is like city names that in New York, Los Angeles, and something like this, and when we apply the binary encoding through this pip installer categories encoding, and inside this when we through the category encoding, okay, class that object is, for example, we represented C through the ce dot binary encoder. If we pass the city column, okay, if we print out this, here you can see this now only three new feature is created. And how it works, so basically it basically assign the binary you, as you know this, for example, in order to represent the category 2, okay, so we have some binary values, okay, 001 0010 something like. So I will explain is in slides. Okay, so how the binary encoding actually works. The thing is, it only creates, here you can see that instead of creating for each unique value inside the categories to each unique column, okay, so instead of this, it creates only three new columns. And how many values we have inside the categories, it will assign okay, a unique integer and convert that unique integer into binary digits. Okay, how it works I will show it. So it reduces the dimensionality, not increase the dimensionality. So therefore mostly I prefer the binary encoder than the one hot encoding. So let's understand how the binary encoding works. So binary encoding basically works, first of all, it assigns a unique integer to each category. Inside, for example, the New York integer is 0, the Los Angeles integer unique integer is 1, and Chicago is 2, or something like this. After that, it converts the each unique integer to a binary representations. For example, 0 is called 000, 1 will be called 001, 2 will be 010, 3 011. The binary, basically it converts it into binary numbers. Okay, after that, then it splits the binary numbers into columns. As we have the inside the binary, we have three basically three digits, so it create the three columns. And the 000 will be 0001 001 will be 0 and inside the column 0, that is 1, and inside 010 will be 010. Split it in the three different columns. Okay, how many digits it will create that number of column. After that, it will final encoding data frame. For example, in New York will be called 000, the Los Angeles will call 100, the Chicago will be 010. So this is how binary encoding works. So I think you will understood about the binary encoding. So let's move to the next encoding type. The next is target encoding. Inside the target encoding, it replaces each categories with the mean of target variable of that category. Okay, what it means, for example, inside we have the categories data like A, B, C, and target is 10110. For example, here you can see that A is occur two times, B is occur two times, something like. And through this, okay, categories, if we apply the target encoding, okay, the mean of each category, and we group by categories, so okay, and if we show this output in a new feature, that is category target encoder, here you can see this target category is A, target is 1, okay, the target B, target is 0. And the how the targeted encoding works, basically it will creates the mean of A. For example, A occur two time, okay, and the two time A target value is first time 1 plus second time 1. 1 plus 1 divided by 2, that is equal to 2 by 2, that is equal to 1.0. Okay, so let's understand this second one. Okay, its value is 0.5. How it comes? So the B occurs two time. The first time it target is 0, and the second time its target is 1. So 0 plus 1 divided by 2, 0.5. So this is how this occurs. So this is how the targeted encodings basically will calculate, and how you can implement it. So after watching this, now you have learned all the encoding techniques practically and theoretically. Okay, so how you can choose the right encoding method, just pause the video and read the slide. And inside this is some practical consideration, also read this. So let's move to the next topic, that is feature selection. Feature selection is the process of selecting the most relevant features from the dataset in order to improve the model performance. Okay, so it will reduce the overfitting and enhance interpretability. Okay, so the importance of feature selection is reduce dimensionality, okay, improves model accuracy by removing irrelevant or redundant features, it helps prevent overfitting and simplifies model interpretations. So how you can implement the feature selections? We have different key methods for feature selections. The first is filter method. Use statistic measures to score feature based on the relationship with the targeted variable. For example, we have a correlation coefficient, we have chi-square test, we have mutual information. In the correlation coefficient, we have basically inside two or more different features. Okay, the most linear relationship between the features will be basically comes in the correlation coefficients. Okay, its values ranges from -1 to 1. 1 means perfect positive correlation, means as one variable increases the other also increases. If the correlation coefficient value is 0, it means that no correlation variables are independent of each other, and -1 means perfect negative correlation, as one variable increases the other decreases. So let's implement the filter method in Python. So inside the code, the fourth section is feature selection. Okay, so in order to implement the correlation matrix in Python, okay, so we have a data. For example, if we have age, salary, experience, and the target variable is lone default. Okay, when we load this to the panda inside the data frame, okay, and through the df.corr method, we can compute the correlation matrix. If I basically print this inside the heat map, here you can see this. For example, the value is okay for of the same feature. For example, age feature is 1, the salary and salary feature is 1. Okay, so the value is between -1 and 1. Okay, the maximum value, for example, this is 0.99. Okay, it's mean that the high correlated two features are salary and experience, or similar you can see it inside this salary and experience. Okay, so basically here this salary and experience, and this is also experience and salary, so both will be the same values. It means that the salary and experience features are more correlated with each other. Okay, so we can pick these two features for the model selection. The highest the correlation value means the more linear relationship between the two values. Okay, so this is the next method of filter based method is chi-square test. Inside the chi-square test, basically chi-square test, through this sklearn dot feature selection, we import the chi2 and the select k best. Okay, we have a data, for example, the age, salary, and experience, and inside the y we target variable, we have the lone default. We apply the chi-square score and p-score through this method, and when we print out this, here you can see that it's showing me the age chi-score value is 5 point this one, the salary chi-score value is 4 5, and the experience, the maximum is salary chi-score value. It means that first filter feature we can select this according to chi-score is the salary, so we can select the top two, for example the salary and then this one. So salary and experience is the most basically selected feature in order to apply for the model selection. Okay, so this is how you can select the features based on the chi-square test. So let's move to the next topic, the wrapper method. Okay, inside the key methods for the feature selection, the next method is wrapper method. Inside the wrapper method is nothing but very simple. We use a predictive model to evaluate the combination of features. Okay, so we have this forward selection, backward elimination, and recursive feature elimination. So this is the automated way to select the features. Okay, so the wrapper method is, you can implement this inside the Python by using the library, that is the sklearn.feature selection, import the RFE, and to the assemble sklearn.assemble method, we use the random forest classifier for automated way for predictive model in order to select the features. Okay, so we use the random forest. Inside the X we have this experience, inside the targeted value we have the lone default, and we can implement this through this line of code, and after that the selected features are, it's showing us the salary and experience, as the chi-square and other methods also give us these top two features. So here you can how you can use the basically predictive model in order to evaluate the combination of features or in order to select the features. Okay, so let's move to the next topic, that is embedded method. So the next method is embedded methods. It is nothing but feature selection occurs as part of the model training. In this we have two examples. We can implement this through the lasso regressions. We can say L1 regularization and with the tree based models, that is random forest or XGBoost. So in order to implement the embedded methods, so first of all I implement the lasso regression through the sklearn.linear model, import the lasso, and inside the data we have these x targeted variable and x features, y targeted variables, and through the apply lasso object, okay, so and lasso dot fit we can basically, and through the output feature import we can import the feature. For example, it's showing us the output as feature imported using the lasso is age is positive and salary is negative and experience is positive. It means that we can select age and experience, something like this. Okay, we can also implement through the tree based features importance. Okay, and inside this I use the random forest classifier, and through this we can basically we can feature importance using the random forest. We can select these top features, and I can also visualize is library. Okay, and inside here you can see that the age and the salary is the two maximum. Basically it's showing the age and then the salary. Okay, age and salary as the two maximum features. We can select this. Okay, so now let's move to the last method for feature selection, that is the dimensionality reduction. Okay, it transforms the feature space into a lower dimension. Okay, so we have two examples. We can implement this through the principal component analysis, that is PCA, or linear discriminant analysis, that is LDA. So let's implement this through the principal component analysis in Python. So this code is mentioned in video description. So the principal component analysis is nothing but to transform the basically the data into a new space or new dimension. Okay, it transformed the data into a new coordinate system where the dimension is called principal component. So basically it ordered it in the first principal component, second principal component. The first principal component basically ordered the feature that are more in order to the variance, okay, they capture. For example, you can understand this process through this example. Okay, so from the sklearn.decomposition we import the PCA, and from the sklearn.preprocessing we import the standard scalar. So basically the first step for implement the principal component analysis is to standardize the data. So okay, so basically through the pre-processing we also import the standardize standard scalar. Inside our data we have the height and width weight of different this that type of data set. Okay, we convert this inside into the data frame, and first we standardize the data through the standard scalar method. Okay, after that we apply on the standardized data the principal component analysis. Okay, and through this if I print the explained variance ratio, here you can see that the inside the first principal component the ratio is 98% and the second component is the ratio is point. So we can select all these features that comes in the first component. So this is how you can basically apply the principal component analysis in order to dimensionality reduction. Okay, so we can also visualize this. For example, here you can see that through this the matplotlib, here you can see that the first component it contains the majority of data 98%, and the second component is very low. So we can also we'll eliminate the second component, all consider the first dimension, first component, principal component of data. So this is how you can implement the feature engineering in Python. And after watching this video, I hope you have understood about the basic concept of feature engineering, all these the possible topics inside the feature engineering, and you can also know about the implementation in Python with example. If you have any question, you can ask your question in video comment section. A question link is also mentioned in video description. You can just go to that specific link and ask your question. I will reply it on your email. Don't forget to subscribe my channel for more informative videos. Stay blessed. Have a nice day.